Thanks for coming out. Sorry, we've got a bit of a cough. We'll see how we go. But yeah, this is basically me having a bit of a chat about building a declarative API in Python. Now, depending on your background in computer science or in programming, if I say the word declarative to you, it could mean a number of rather different things. What I really want to get at today is a concept that I think about in terms of red code and green code, or you might have heard it in terms of accidental versus inherent complexity. And if you haven't heard of it, the best example is the humble for loop, right? What I'm trying to do here is iterate over a sequence of items and call some function. And if I were in C or a C-like language, this is approximately how much code I'd have to write. There's two kinds of code here. The code in green is the stuff that I actually want to do, right? I want to iterate over this sequence and do something. And the code in red is not related to what I want to do. It's extra fluff that I have to write in order to translate my intention into something that the computer can understand. And one of the things that we love about Python is that, for example, iteration is a lot cleaner. There's a lot more green and a lot less red. You know, I don't really care what I name the variable that I'm using to iterate over this sequence, but there's a lot less noise in this code. It's a lot more about what it is that I want to do and less about the fluff I have to do to convince the computer to do it. More green, less red, more what, less how. Okay, and if you're designing a computer system or an API for developers, which is sort of where I'm coming from here, that's really what you need to aim for. Of course, the red code has to go somewhere. Eventually, this has got to turn into assembly instructions, right? But the point is that you know, you shouldn't be spreading it out all over your code. You should get it right, then you should hide it and reuse it over and over again. So the reason we have such a nice for loop in Python is because the Python core developers get their hands dirty with all of the nitty-gritty and the bits and pieces and the red code that makes iteration happen. So your challenge, if you're designing an API to be used by other developers, please try not to leak red code all over your users. And this is what have I got? Yeah. So this talks a little bit about some things to think about it and some common patterns when you come to building up some APIs. It's a little bit about how to use Python and some of the more quote advanced features of Python or quote magic features of Python to make it happen. But really it's all example. And I want to basically rebuild a little library of mine, or a smaller version of it, as a way of discussing this topic. So most of all of my slides are code with a little bit of commentary and a little bit of highlighting, so hopefully I say enough words to make it all make sense. Here's what I want to do. This is a trimmed down version of a library I have called DXML, which is if you take something like Django's ORM and rip out SQL and put XML in its place. Yeah, thrilling. This is the idea. So we have, say, a class in Python. It's a person, right? I would like to be able to create an instance of this class and render it into some sensible XML structure. Right? Conversely, I want to be able to take that XML and pass it back into a person object from whom I can, you know, access various fields. They have the appropriate types for these fields, and the API prevents me from doing something silly, right? So it's about trying to take an XML schema and capture it as a set of Python classes that help me work with that document structure more effectively. You know, you could take a similar sort of approach to a lot of different problem domains, but this is a small enough example that we can get going. So there's a little bit of an obvious starting point here, right? We'd have some base model class, and then you, as a user of this library, would inherit from model. And you say, I'm declaring a person object, all right? What do I put inside my class definition? And basically this whole talk is about cleaning up what goes here. So if you think about it, in order to implement this library, the model class is going to need to know what XML tag it's expecting, right? It's going to need to know what fields to look for contained within that tag. And at this point in the game, that basically means what the fields are called and what types they're supposed to be. So that's not a lot of information. And if we didn't care about making a friendly API, we could just say, well, you're declaring a model. You need to tell me what the tag name is. You need to tell me a list of the fields, and you need to tell me the name you want it to have in Python, the type you want it to have, and the name of the tag you want it to turn into in XML. I could take that, if I had that class, I could implement render and parse, right? Put the tag name out as XML, go over all the fields and turn them into subtags, put the closing tag on it and return it. It's easy, you've got all the information you need. I don't want to get into this code, this is just to show you the starting point. Similarly, it's very easy for me to given that information, I can parse a structure out of XML. Right? I can get the root tag, I can check that it's got the expected tag name, I can iterate over the child nodes of that tag and match them up with the fields that you've told me to expect, and just set them as attributes on the object and we're done. Okay? So the implementation of that idea is quite straightforward. What I'm interested in is how we can make it easier to use and harder to use incorrectly. So is there much red code in this sort of initial API? And there's nods all around. Yes, there is. To begin with, this is incredibly redundant. It would, you may want to map from a tag name to a different class name, that's fair enough, but if you're going to go with what would be a sensible default, you shouldn't have to repeat yourself explicitly. And again, a sensible default would be to have the names of your field subtags matching the names of your fields in Python. More importantly, this is awful. A tuple of tuples of various properties, right? It's very, very easy to get that wrong. You could put them in the wrong order and get weird type errors at runtime. You could duplicate fields with different definitions and so forth. So the first thing we can start from is saying, look, let's let you elide some of those details and we'll fill them in and fix them up with some sensible defaults. And quite a common pattern that you'll see, if I go into the pattern slide, there we go. Quite a common pattern that you'll see is like you'll have some class and then you'll need to do some post-processing on it to fill in some defaults or make sure that it's got sensible things defined on it. This might be registering a plugin, for example. It's quite a common pattern to take a class and then do something with it after it's been declared. I think Python 2.6 has class decorators that let you do this, but that's still noise, right? I'm saying I'm building a model, and then I'm building a model again. So if you find yourself in a situation like this, I propose using metaclasses as a solution. And there's probably people in the audience who will cringe at seeing the word metaclass and the word solution in the same line. And they're rightly considered deeper magic than you'll almost never need, but I don't think people should be terribly afraid to deploy them in situations where it can improve your code. The problem with metaclasses is that people have this very strong distinction between values and types, which just doesn't exist in Python, right? So Python has this thing called list, and if you call it, it creates a new list. Python has this thing called dict, and if you call it, it creates a new dict. And Python has this thing called type, and if you call it, what do you think it's going to create? That's going to give you an error. Because types have information, right? But if you give it enough information, you say, well, my type is named this, it has these base classes, it has these attributes, that'll go ahead and give you a new type. And actually, every time you write a class statement, this is what Python does behind the scenes. It turns it into a call to the type built in. Similarly, you can subclass from something like list and customize the way that lists are created. So this is a list that doesn't like the number 7, all right? And if you use this customized subclass of list, you can customize the behavior. In exactly the same way, you can subclass from type and customize the way that types are created. And that's what I'm going to do. So this is quite possibly the simplest application of a metaclass that you could do that does something useful. I'm going to create a new type of type, if you like, so a extended type. It's called model metaclass, and I'm basically going to do everything that type normally does. So I'm going to go ahead and create a class, basically, and then I'm going to do a bunch of extra stuff afterwards. So I'm going to, check if you haven't given me a tag name in your list of attributes, I'm going to default to the name that you declared on the class. If you haven't given me a list of fields, I might set it to an empty tuple, I might give you an error, something like that. if you haven't given me a tag name on some of your fields, I'm going to go along and fix that up. And basically, this is a way to hook some extra post-processing logic into your classes. You give this magic little definition, you say Python, instead of calling out to the built-in type constructor, call out to this customized version. Right? And then everybody that declares a subclass of our model, we're going to get control of that declaration when they're finished, and we're going to be able to fix it up and do interesting things. Okay, so we can get down to this with a little bit of magic, and that's looking better already. All right, there's a lot less noise, there's a lot less redundancy going on. What happens if I want to do something slightly more complex like this, right? I want to say, well, actually, age is an attribute of the person tag, it's not a subtag. Then I need to have additional information about my fields. All right, so we'll add another item to that tuple to say if it's a tag or an attribute. And then maybe I've got tags that are optional or required, and very, very quickly this becomes a huge nightmare, right? You will get this wrong. Everyone will get this wrong. What you need to do is factor all of this out into something that's a little bit cleaner, something that fills in the defaults for you, something that can help you out. So a helper class declared something like this, right? Instead of saying, here's my tuple of various options that don't have names, I'm declaring a field, it's of type string. I'm declaring a field, it's an attribute, but it's optional. And obviously that can be just a normal class, it's got a bunch of optional keyword arguments, and it fills in sensible defaults for you. What's nice about doing that is you can actually defer a lot of the logic for fields into this helper class now, because you're not just dealing with dicts and tuples of tuples and so forth. For example, you can have the meta class tell the field about its own name. All right? So we go from this declaration, all of a sudden I've got an object to say, right, I am a field of this type, I have this name, I've got all these various properties. So that field can contain all of the logic for dealing with those different cases. Nope, I haven't got that slide, sorry. This is a stylistic point, because I've written a couple of libraries in this, using some of these techniques. You can either have this generic field type and give it a type that it's supposed to use, or you can do what, for example, Django does, which is say, well, I have all these different types of field. I have a string field and an integer field. I prefer this approach, having tried them both, because it means that you can create customized field classes and hand off a bunch of work. So this is our render method. And originally, it was doing all of the work. Like, it got the raw information about our fields, and it figured out, well, this is optional, this has got this name, this is whatever. By factoring it into a helper class, you can just hand off all of that work, and then people can customize it and override various bits and pieces. So it helps to clean up your implementation as well. How are we going? Okay, so that's not looking too bad. How are we going for noise, for red code here? Well, this is mess. I should point out that this, if I take the red code away, is basically the API that you get out of something like C-types for declaring structs and so forth. It's not bad. There's not too much noise there, but that, you don't need to know about that. It's pretty obviously we're declaring fields. Why do I need to put all of this extra structure around it? It'd be much nicer if we just said this, right? Which if you've played with an ORM, this is pretty obvious, right? I have a person, there's a name, it's a string field, there's an age, it's an integer field. No problem, right? Oops. We've lost some very important information here, because the class statement will turn that into a dict of, name is this, age is this. What we've lost is the information that, well, name is the first subtag, age is the second subtag. Now, ordering information in something like XML or SQL for fields in your database is very important. And although the ordering information is still there in your source code, Python throws it away when it goes to execute that class. So we want to restore it, and you have to resort to a little bit of trickery. You don't have to do this trickery in Python 3, because this is such a, well, I'm not going to say common, but it's such a, perhaps a common use in the context of meta classes, that you want to be able to preserve the ordering information from your declaration. Python 3 actually did a bit of an overhaul of the meta class system and added some hooks that let you do this in a much cleaner way, but this is the Python 2 version. So trickery, here's what we're going to do. We're going to keep a hidden global counter. I love the grimaces. I love grimacing in my talks. Every time you instantiate a new field object, it's going to grab the current value of that counter. I've highlighted the most important line. It's going to increment that counter to say, well, I've now created another field. And then these field objects are just going to order themselves by the order in which they were created. Okay? So when Python gets around to executing this, string field gets order 0, integer field gets order 1, and we've got enough information to restore that. I'd love to chat with you about this. So, you know, when we're back in the process of post-processing our class, we can get our list of fields and we can sort them back into the order they were supposed to be in, and we've recovered that information. The final point is I've kind of skipped over something here. My initial slides, I said we want to be able to do stuff like this. I want to be able to say, I've declared age as an integer, so if you give me something that's not an integer, I want to give you an error straight away. That's a very helpful piece of API design. And this is a very common pattern, and there's a very common solution to it, which is to construct descriptor classes, which are, again, this sort of thing that you often hear about begrudgingly or secretively as something that you should avoid, and that's probably true if you don't need them, but they're very, very useful. The basic idea is the following. When Python goes to set an attribute on your object, it doesn't just bung it straight into your dict, right? The first thing it does, simplified of course, is to check whether your class defines something with that name. So I'm setting attribute. Checks if your class defines something with that name that has a set method, __ set method. If it has such a method, that method gets control of the attribute setting process, and it gives up. If you don't have that method, we fall back to the default. So what I'm going to do is basically on my field class, I'm going to create this descriptor method called set. So when you go to set a value on the object that corresponds to this field, this method gets control by the way that Python's attribute logic works. And I'm basically going to say, oh, well, I'll validate that value. I might convert it into the appropriate type, and then go ahead and store it on the instance where it would have wound up eventually. And similarly, you can customize the get method to do something similar and rip it out and you know, post-press it as it's being read back out of the object. So basically, that will give us everything that we'd like out of a library like this in what I think is a very red code-free API. And once you've started down this road, you can start doing more interesting things like nesting your classes, so you can have a group with a list of people that corresponds to a collection of person subtags and this sort of thing. You know, the Django ORM has all of these great different subfield types to nest and relate models in various ways. But once you've kind of taken these little bits of meta-programming functionality and composed them together in an appropriate way, you can build structures like this very declaratively and eliminate a lot of opportunities for people to get things wrong, eliminate a lot of opportunities for people to be confused about what their code is doing. I like to conclude all of my talks with an admonishment to sensibility. And it's very easy to get really excited about, oh, these awesome meta-programming facilities that Python has, and go completely overboard with them. I'm going to return to the for loop for an example like that. There's a little bit of red code in there, and certain other language purists will tell you that the most, the highest signal-to-noise ratio form of this iteration is map, right? I want to iterate, I want to do something on this sequence, and there's absolutely no red code there whatsoever, which is fine, and it works in languages that are geared that way. I put it to you, and I think sort of with Python 3, this was a generally accepted consensus of the community that most often that's harder to read than that in Python for a Python API. So this talk's all about sort of interesting things that you can do because I find them interesting and they're fun to hack with and so forth. But at the end of the day, if you're designing an API, it's all about balance and it's all about trade-offs. And if you can hide a lot of red code by doing a little bit of magic behind the scenes, awesome. But it's very much a balancing act, and every time you pull out a meta class or you pull out a descriptor, you're making your implementation a little bit more difficult, and you're making the maintenance and extension of that implementation a little more difficult. So it has to be a very carefully balanced act. And I think I'm actually running under time, which is unusual for me. So this is DXML, this is the project that's based on, and it came out of a real life need. I was implementing a WebDAV server, and WebDAV is all about XML, and it's all about making sure that XML is extremely well formed and has things in the correct order and so forth. So if you want to play around with a proper, full-on version of that stuff, that's there. And thanks very much for coming out, and I've got lots of time for questions.
Okay, like Ryan said, we have plenty of time for questions. Are there any questions?
I just wanted to get your thoughts on working with other programmers with these sort of systems. By hiding the red code somewhere else in a way, so if I didn't do that, I could just go in and override this method, and just maybe some general tips or discussions about that.
One of the criticisms that's often levelled at metaclasses in Python, macros in Lisp, and sort of these metaprogramming techniques is that, well, I understand them, but my colleagues mightn't understand them. And that's true to an extent. I think sometimes that's used as a little bit of an excuse to not bother. And you certainly have to be very careful in your application of it. There's nothing in the implementation of a metaclass, for example, that will stop you from further customizing that. It's just that you need to be aware that there are metaclasses involved. You need to be aware of where they are and how they're structured. It's very easy to write a one-off metaclass that does a bunch of crazy stuff and isn't open for extension or modification. But it's not that much more of a design challenge to write good extensible code at the meta level than it is to write it at the object level, if you're comfortable there. Yeah, it's definitely a trade-off. A potentially good approach for complicated projects is to factor out, certain really hard aspects of it and give it to your best developers. Like that's certainly a valid approach, and this is the sort of thing that can help you achieve that as well. To sort of, if you've got a very nice barrier that's quite simple between really horrible code and the rest of your code, that's not a bad thing in general. But yeah, definitely a lot of potential social issues involved in doing this sort of thing.
You're going to make me come upstairs, aren't you? We need the mic.
You mentioned that in Python 3 they have a solution for the ordered field issue. Are you able to just summarise?
Yeah. Basically, when Python executes your class, this, def, whatever, it basically creates a new namespace and then executes the body of your class in that namespace. Right? In Python 2, that's always a dictionary, which is why you lose ordering information. Python 3 metaclasses have a special method. I think it's called __ prepare or something. Basically, the first thing Python does is call that method. Whatever it gives back is used as the context for executing the body of the class. So if it gives back a regular dictionary, you get regular behavior. If your metaclass says, well, execute the class body in an ordered dictionary, for example, then that maintains the order in which things are declared in the metaclass. And you can do all sorts of wacky things, return whatever you like. I think when they did the PEP for that, I don't recall there being a single other example other than ordered dictionaries of what you could sensibly return from this method. But I'm sure someone could come up with something fun.
Are there any other questions upstairs while I'm up here? Or downstairs? No? Okay then. Thank you very much, Ryan. Sorry, there was another question.
Hi there. Could you potentially override like monkey patch object and change the meta class for object?
I actually had exactly that thought at about 9:30 this morning. I mean, I don't think you can actually change the base class of object, but what you could do is define a new thing called object and shove it in the built-ins dictionary, and then everybody else that thinks they're safely inheriting from objects actually inheriting from your evil version. But don't do that. Almost all of my talks end with a big slide that says don't do that.
Okay, any more? Last call this time. All right, again, thank you very much, Ryan.
Thank you.